Hello my dear students, welcome back to Fluid Mechanics lecture series. I am your SumamMiss. Today we are continuing the discussion on open channel flow. What is open channel? So let me start with the definition of open channel. Open channel is a sloped liquid flow passage having solid boundaries with the top surface exposed to atmosphere. Unlike pipe flow where the flow is taking place under pressure, in open channel flow every section is exposed to atmospheric pressure. So we have learned previously that the total energy at any section in the pipe can be written as P by rho g plus Z plus V square by 2g, where P by rho g indicates the pressure head, Z is the position head, and V square by 2g indicate the velocity head. And we have also learned that the pressure energy is decreased in the direction of the flow. If you are writing the expression for total energy for an open channel flow, it is equal to Y plus Z plus V square by 2g. So figure shows the section of an open channel. So Z is the position head and Y that indicates the flow depth, and V square by 2g is the velocity head. So if you are comparing the total energy equation for this pipe flow and in open channel, we can see that the pressure head in pipe flow is analogous to the flow depth in an open channel. Now, if channel bottom is taken as data, total energy per unit weight, that is equal to E equal to Y plus V square by 2g, or it can be written as Y plus Q square by 2ga square, where V equal to Q by A. So we can say that specific energy is the energy per unit weight of water measured above the channel bottom. So the concept of specific energy is very useful in the solution of many open channel flow problems. Now let us discuss about the specific energy curve. So the expression for specific energy E equal to V square by 2g plus Y, or it is equal to Q square by 2ga square plus Y. So the first term represents specific kinetic energy and the second term represents the specific potential energy. So specific energy E can be written as Ek plus Ep. Ek is the specific kinetic energy and Ep represents the specific potential energy. So for a given channel section and discharge, specific energy E equal to function of Y, or Ek is a function of Y, or Ek equal to Q square by 2ga square is a function of Y, and Ep equal to Y. If you are plotting variation of E with respect to Y, which is the summation of Ek plus Ep. So initially we can plot Ek with respect to Y. So this parabolic curve represents the variation of Ek with respect to Y. In the next step we can plot the variation of specific potential energy with respect to Y. So that means Ep equal to Y, which represents a straight line by making an angle 45 degree with respect to horizontal. So this straight line which represents Ep equal to Y. But specific energy E equal to Ek plus Ep. If you are adding the value of Ek and Ep for corresponding value of Y, then the resulting curve is represented in blue color. So this curve represented as E equal to Ep plus Ek, which is equal to Y plus V square by 2g. It is indicated by the notation ACB. So this curve ACB represents the variation of E with respect to Y, and it is called specific energy curve. So this curve ACB has two limbs, CA and CB. The limb CA, which is going asymptotically towards this energy axis, whereas the limb CB, which is going asymptotically towards this potential axis. And when you are observing this curve ACB, you can see that when the Y value increases from low to high, the specific energy decreases and it reaches a minimum value. Then it started increasing with increasing value of Y. So the point C, which represents the minimum value of specific energy, and the flow condition corresponding to this minimum specific energy, that is called critical flow condition. Let us consider a point on this energy axis, and if you are drawing a vertical, then it will cut this specific energy curve at these 2 points. So these are the 2 points. That means for each specific energy other than this minimum specific energy, there are two depths are possible, y1 and y2. So the depth y1 is below this critical depth yc, and the depth y2 which is higher than this critical depth yc. So these two depths y1 and y2 are called alternate depth. So we can say that for each specific energy other than this minimum specific energy, there are two depths are possible and they are called alternate depth. The point C where specific energy is minimum. So how will you find out the minimum value of specific energy? So for a given channel section and discharge, E is the function of Y. The condition of minimum specific energy can be determined by differentiating this E with respect to Y and equating to 0. So E equal to Q square by 2G A square plus Y. So if you are differentiating this expression with respect to Y and equating to 0, then it becomes 1 minus Q square by GA cube into dA by dy equal to 0. So in this, Q is constant and A is a function of Y. For the channel section, as shown in this figure, the top width T represents the width of the channel at the free surface. So consider a small strip of water with thickness dy. So area dA which is equal to T into dy or T equal to dA by dy. So if you are replacing this dA by dy in terms of T, then this equation becomes 1 minus Q square T by GA cube equal to 0 or Q square T by GA cube equal to 1. So this condition represents the minimum specific energy. So this equation represents the condition of minimum specific energy irrespective of the shape of the channel. Now let us discuss about the characteristics of specific energy curve for a change in discharge. This curve represents the specific energy curve for this discharge Q. When discharge increases, that is Q1 higher than Q, the specific energy curve shifted forward in such a way that the critical depth obtained corresponding to the minimum specific energy is higher than the earlier critical flow depth corresponding to Q. Similarly, if discharge decreases, the specific energy curve shifted back in such a way that the critical flow depth corresponding to the minimum specific energy is less than the earlier one, which is corresponding to the discharge Q. To conclude, we can say that for a given channel section, critical flow depth changes for a change in discharge. Critical flow depth increases when discharge increases. Similarly, critical flow depth decreases for a decrease in discharge. We have learned previously that the condition of minimum specific energy, that is dE by dy equal to 0 or Q square T by GA cube equal to 1, but Q equal to AV and A by T, that is equal to hydraulic mean depth. So if you are replacing Q in terms of AV, then A by T, that is equal to D, then this equation can be modified as V square by GD equal to 1 or V by root of GD equal to 1. What is V by root of GD? It is nothing but Froude number, which is the ratio of inertia force to gravity force. So from this expression we can say that at the critical flow, the Froude number is equal to unity. So at this stage we can say that F equal to 1 represents the critical state of flow. So the expression for E equal to y plus v square by 2g, that is equal to y plus q square by 2ga square. So we can express this expression in terms of q as q equal to root of e minus y into 2ga square. In a given channel section, for a given value of specific energy, the condition of maximum discharge is obtained by taking dq by dy equal to 0. So if you are differentiating this expression with respect to y and equating into 0, then this equation becomes root of 2g into dA by dy into root of e minus y minus a divided by 2 into root of e minus y equal to 0. So root of 2g equal to 0 or this term equal to 0. What is dA by dy? It is equal to t, that is the top width of the channel. If we are taking a common LCM, then modifying this expression, then you will get as E equal to y plus a by 2t. So if you are replacing E as y plus q square by 2j square, then this equation becomes y plus q square by 2j square equal to y plus a by 2t. So if you are cancelling this y and modifying this equation, then this equation turn into q square t by ga cube equal to 1. So that means in a given section, For a given value of specific energy, the discharge is maximum when the flow is critical. So please remember, at critical state, specific energy is minimum for a given discharge, whereas in a given channel section, for a given value of specific energy, the discharge is maximum at a critical state. Now the session comes to an end. For the time being, it is enough. All the related problems are discussing at the end. Next video discusses about. Please don't forget to press the bell button to get the notification of next video. Thank you.